Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the electromagnetic theory, electrical of ESE previous year questions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to mobile. If any improvements are in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the first question. See the question here. If A bar is equal to aero cap plus A phi cap plus AZ cap, then the value of the closed line integral of A bar dot DL bar around the closed circular quadrant shown in the given figure. So here in this circle you have to make a closed loop circle. So around this circle the closed line integral of A bar dot DL bar is equal to, what is the value we need to figure out. In the question they also given the closed loop counter and also they have given a vector A bar. So based on this we have to find the value of this closed line integral of A bar dot DL bar we need to figure out. So out of these four options, option A, pi is the correct solution of this question. So let's solve this numerical. So in this question they are given A bar is equal to aero cap plus A phi cap plus AZ cap. So and also here they are given a counter in such a way, this is a closed counter. So in this path they are going to travel this path in this closed counter, then what is the closed line integral of A bar dot DL bar we need to figure out. This is basically an x-axis, y-axis and z-axis. So now here I am going to solve this question in two methods. The first method is called as the Stokes Theorem, which is closed line integral of A bar dot DL bar is equal to open surface integral of del cross A bar dot ds bar. This is the Stokes Theorem. This Stokes Theorem is going to tell you about the circulation. So now we can do either by this one, by solving this LHS, or either we can solve this by RHS, because both are same. So now in the first method I am going to solve this RHS and then I am going to show you the result. In the second method I am going to solve this LHS and then I am going to show you the result. Both will be same. So in this first method I am going to solve this RHS because LHS is equal to RHS. So whatever the answer you are going to get in the RHS must be equal to LHS. So now I am going to solve this equation. So this is called as the Stokes Theorem. So now we have to find what is a del cross A bar. Del cross A bar, this is basically an cylindrical coordinate system. In cylindrical coordinate system, basically del cross A bar is equal to 1 by rho, determinant of aero cap, rho A phi cap, AZ cap, dou by dou rho, dou by dou phi, dou by dou z, aero, rho into A phi into AZ. But here aero is equal to 1, A phi is equal to 1 and AZ is equal to 1. So in place of aero 1, A phi 1 and AZ 1. So I have replaced same thing here. So if you solve this determinant, then finally you are going to get del cross A bar is equal to 1 by rho into AZ cap. And also here the increment in length in cylindrical coordinate system is d rho into aero cap plus rho into d phi A phi cap plus dz into AZ cap, where d rho is a small amount of change in aero cap, rho into d phi is a small amount of change in A phi cap, and dz is a small amount of change in AZ cap. And also I want to know what is the small amount of area vector in this closed loop line, in the closed line integral, what is a small amount of ds area. So basically this is in the plane of xy plane. So therefore if you go in this direction the amount of change is d rho, and if you go in this direction the amount of change is rho into d phi. So this is the area, this is the area vector. So area is equal to d rho into rho d phi, and the area vector will be perpendicular to this open surface. So therefore this is AZ axis. So therefore we can say ds bar is equal to rho into d rho into d phi AZ cap. So we know the value of del cross A bar and we also know the value of ds bar. Just we have to do the dot product of these two vectors. So if you do the dot product of these two vectors, both are AZ cap and AZ cap will become 1, and here 1 by rho into rho d phi. So rho get cancels. So finally we will get d rho into d phi. So therefore del cross A bar dot ds bar is equal to d rho into d phi. And now we have to do the surface integral. So surface, so we have to do over this total surface we have to do. Say the length is changing from 0 to 2 and the angle is changing from 0 to pi by 2. So therefore we can say rho is changing from 0 to 2 and phi is changing from 0 to pi by 2. Then only we can cover this total plane. So therefore now rho is equal to 0 to rho is equal to 2, phi is equal to 0 to phi is equal to pi by 2. So we have to do the integral d rho into d phi. These both are independent of each other. So therefore phi is equal to 0 to pi by 2 d phi into rho is equal to 0 to 2 d rho. So this value integral will give you pi by 2 and this value will give you 2. So pi by 2 into 2 is nothing but pi. So pi is the correct solution of this question. So now we can do this question even in our another method, which is the closed integral of a bar dot dl bar. So I am gonna make this path into 3 different paths. This is the path 1, path 2 and path 3. So therefore we can say for the path 1, for path 2 and path 3, if we add all these things, we are going to get the closed integral of a bar dot dl bar. So in the question they are given a bar is equal to a rho cap plus a phi cap plus az cap, and dl bar, a small amount of increment of length in the cylindrical coordinate system, is d rho into a rho cap plus rho into d phi into a phi cap plus dz into az cap. So you have to do the dot product of this one because a bar dot dl bar. So if you do the dot product, the corresponding element should be multiplied. So therefore we are going to get d rho plus rho d phi into plus dz. So d rho plus rho d phi plus dz is the a bar dot dl bar. So for the path 1, the things which are variable are, see, the rho is changing from 0 to 2, but phi is a constant which is equal to 0, but and also z is equal to constant. So therefore we can say is a variable from 0 to 2 and phi is a constant. So if phi is constant, then d phi will be always equal to 0 because change in phi is 0, and we can say phi is equal to 0 degree, the path 1, and z is equal to constant. So if z is equal to constant, then we can say dz is equal to 0 and the actual value of z is here is equal to 0. So now with these conditions we have to substitute in this one. So therefore a bar dot dl bar. So therefore here dz is equal to 0 for the path 1 and d phi is equal to 0. So therefore these two terms will become 0. Only this is the term which is going to remain, and rho is changing from 0 to 2. So rho is changing from 0 to 2. So if you do the integration of this one, we are going to get the line integral for the path 1 value is 2. So now for the path 2 I am going to do the integration. So for the line integral I am going to do for the path 2. So for the path 2 the rho value is fixed, which is rho is equal to 2 and the angle phi is changing from 0 to pi by 2. So therefore now the constraints for the path 2 are rho is equal to constant, its value is equal to 2. So if rho is a constant, then we can say the change in rho value is equal to 0 and phi is equal to variable because it is changing from 0 to pi by 2. So if phi is variable, we can say d phi is not equal to 0 and z is equal to constant and its value is equal to 0. So if z is equal to constant, we can say dz is equal to 0. So now we have to substitute these constraints in this equation. So therefore here, so d rho is equal to 0. So d rho is equal to 0 and also dz is equal to 0. So only thing we are going to get is rho d phi, but the value of rho is a constant which is equal to 2. So therefore 2 into d phi. So the integral is from phi is equal to 0 to pi by 2. So if you do the integration of this one, we are going to get the pi. So pi is for the path 2. So for path 1 we got the answer 2 and for the path 2 we got the answer pi. So we have to go for the path 3 and then we have to add this 3 results. Then we are going to get the closed integral of a bar dot dl bar. So now I am going for the path 3 from this position to this position. So therefore rho is changing from 2 to 0 and phi value is constant which is equal to pi by 2 and z is equal to constant which is equal to 3 which is equal to 0. Z value is constant which is equal to 0. So with these constraints we have to solve this for path 3. For path 3 the constraints are rho is equal to variable and it is changing from 2 to 0. So we can say when rho is variable, so d rho is not equal to 0 and phi is equal to constant, its value is equal to pi by 2. So whenever the phi is constant, we can say change in phi is equal to 0 and z is equal to constant. So we can say z is equal to 0. So therefore dz is also equal to 0 because it's a constant value. So keep this constant in this above equation, in this equation. So therefore d phi is equal to 0, 0 into anything is again 0 and dz is also equal to 0. So these two are eliminated. Only this is a thing which is remain. So d rho, and we have to go, the rho is changing from 2 to 0. So 2 to 0. So if you do the integration, we are going to get minus 2. So for the path 3, we got the line integral as minus 2. So for the path 1 we got plus 2 and for path 2 we got pi and for path 3 we got minus 2. So if we add all these three quantities, 2 and minus 2 are going to get cancelled. So final result is equal to pi. So pi is the correct solution of this question. So we have solved this question in the two methods. So for the first method we have solved this one RHS part and for the second method we solved by the LHS method. So both this method are going to give you the same result. So in the examination it is up to you which method to choose. So now we are going to solve the second question. See the question here. Which of the following equations is correct? So out of these 4 options, only one option is correct. So we have to figure out that option. So out of these 4 options, option B is the correct solution of this question. So let's solve this numerical. So in this question they are given 4 options and we have to choose only the correct option. So this is option A. They are given the statement x cap cross x cap is equal to mod of x cap whole square. This is what they are given. But actually x cap cross x cap is nothing but 0 because they are the parallel vectors, or we can say they are the same vectors. So angle between them is 0. So sin 0 will be definitely equal to 0. So therefore we can say the cross product of two parallel vectors is equal to 0. But this one, the magnitude of x cap, it's a unit vector, its length is 1. So 1 square is equal to 1. So we can say this LHS is equal to 0 and RHS is equal to 1. So definitely 0 is not equal to 1. So therefore we can say this option is wrong. So the actual statement has to be here x cap cross x cap is never equal to mod of x cap whole square. So though in the option A they are given like this, so option A is the wrong option, and let us see the option B. So option B they are given equation like this: x cap cross ay cap plus ay cap cross x cap is equal to 0. Definitely x cap cross ay cap is nothing but az cap, and ay cap cross x cap is nothing but minus az cap. So both are opposite of each other. So you can cancel these two equations, two terms, then we are going to get 0 is equal to 0. Yes, LHS is equal to RHS. So therefore we can say whatever the equation given in the option B is the correct one. And let us see the option C. The option C, they are given the equation like this. So we have to check whether this equation is correct or not. So basically ay cap cross az cap is nothing but ax cap, and az cap cross ay cap is minus ax cap. So I am going to take this negative outside. So this is a positive and this is a negative. So both are opposite vectors. We can say there are 180-degree phase angle between these vectors. So therefore we can say these two are opposite vectors. They don't have to be not equal. So therefore we can say this option is also wrong. So therefore we can say this is never equal to this one. So therefore whatever the option they are given, it is a wrong option. And option D, in the question they are given like this: ar cap dot h cap plus h cap dot ar cap is equal to 0. This is what they are given. But actually we know that dot product satisfies the commutative property. So we can go for ar cap dot h cap is equal to h cap dot ar cap, because it is the dot product satisfies the commutative law. So therefore you can go for a into b or b into a, both are same. And if you take this one to the LHS, it is nothing but minus. So ar cap dot h cap minus h cap dot ar cap is equal to 0. This is the actual equation, but in the question they are given in opposite manner. So this is never a equal one. This is the actual correct equation, but the option which is given in the option D is wrong. The statement given in the option D is wrong because it has to be negative, then only it is equal to 0. Otherwise if it is a positive means it is not equal to 0. Whatever the statement given in the option D is wrong. So therefore out of these 4 statements, only option B is the correct statement. So option B is the correct solution. So now we are going to solve the third question. See the question here. Match list 1 term with the list 2 type and select the correct answers. So we have to match the list 1 and list 2. So out of these 4 options, option A is the correct solution of this question. So let's solve this numerical. So in this question they are given list 1 and list 2. So we have to compare these two. We have to make a correction. Means we have to match this list 1 and list 2. So basically here curl of f bar is equal to 0. Curl of f bar is equal to 0 means we can write in curl of f bar is equal to 0 means there is no curling effect. There is no curling effect means there is no closed loops. Only it is diverging outward, or whether it can be converging or diverging, but there are no closed loops in this field. So therefore no curling means we can say it is either diverging field or we can say it is irrotational field. So therefore now it is also called as a conservative field. So whenever a curl of f bar is equal to 0, it indicates that there is no curling, means it is always diverging, or we can say it is a irrotational field, and also we can say it is a conservative field. The example of this phenomena is called as electric field. Static electric field is always diverging. There is no curling effect present in a static electric field. So this is called as the first one. So we can match the curl of f bar is nothing but it is a irrotational. So it is a irrotational. So now for the second one, divergence of f bar is equal to 0. So divergence of f bar is equal to 0 means the field is not diverging, means we can say simply it is a rotational fields are present, means we can say the closed loops fields are present in this. Whenever the divergence of f bar is equal to 0 means the curling is present, or we can say it is also called as a rotational field. The example is the magnetic field, because magnetic monopoles never exist, only dipoles are going to exist. So because of that always the closed loops are going to form in a magnetic field. It is called as a solenoidal field or rotational field. So therefore we can say it is a no diverging means there is no diverging means curling is present, or we can even say it is a solenoidal field or rotational field. The example is magnetic field. So therefore divergence of f bar is nothing but this is called as a solenoidal field. Suppose here let me tell you 2 important null identities. These are always going to hold true, which is The first phenomenon is the gradients, divergence and curl. Gradient is always applicable only on a scalar function, and the divergence and the curl can be applied on a vector field. So therefore now means gradient can only apply on the scalar field, divergence and curl can only apply on the vector field. So therefore the null identities are always true, which are the curl of gradient of any scalar function is always equal to 0 no matter whatever the scalar function, and always the divergence of curl of any vector field will be always equal to 0. See, the curl of divergence of any scalar function will be always equal to 0, and the divergence of curl of any vector field will be always equal to 0, because the gradient of any scalar function will be always perpendicular to the scalar function. So means it is orthogonal to the field, so means it is always diverging, and the curl of any diverging field will be always equal to 0. That is the reason the curl of divergence of any scalar function will be equal to 0. And the second property is divergence of curl of f bar is equal to 0. It indicates that curl of f bar is nothing but there is a curling effect present in a field. So curling is nothing but it is not equal to 0, and we can say divergent. Already the field is curling, there is no divergence, so therefore we can say divergence of curl anything field is nothing but 0. These are the null identities which are always true. And the last one is divergence of gradient of any scalar function is equal to 0. It means that the divergence of gradient of any scalar function is equal to 0. Then we say this equation is nothing but Laplace equation. So simply we can write del square phi is equal to 0. If this is the case, then we can say this is called as a Laplace equation. So therefore this is called as a Laplace equation. So this is the last one, right? Divergence of theta. So theta is nothing but, let me assume this is a vector. So therefore now here this is a vector, right? So divergence of theta is nothing but it is a scalar quantity, and divergence of scalar quantity is not defined. So therefore we can say this equation is not defined. So divergence of, suppose let me assume theta is a vector field, so therefore we can say divergence of theta is nothing but it's a scalar. So divergence of scalar, see, divergence is only applicable for a vector field but not for a scalar field. So therefore we can say it is not defined. So therefore the last one is not defined. So therefore A goes to 2, B goes to 3, C goes to 1, and D goes to 4. So therefore this is the correct solution of this question. So now we are going to solve the fourth question. See the question here. So now we are going to solve the fourth question. See the question here. An electromagnetic field is said to be conservative when? So when the electromagnetic field is said to be conservative, at what condition? So out of these four options, option C is the correct solution of this question. Whenever the curl of field is equal to 0, then we say it is a conservative field. So let's solve this solution. So here in this question they are asking at what condition the field is conservative. See, whenever a curl of any field is equal to 0, then we say whenever a curl of any field is equal to 0, then we say it is a conservative field, because here suppose the curl of electric field is equal to 0, because it is always diverging, so there is no curling effect, or we can say there is no irrotational. We can say it is a irrotational field, means there is no rotational fields are present, means or no closed loops are present. So therefore we can say it is diverging, or we can say there is no curling is present, or we can even say it is a irrotational field or the conservative field. So basically here with the help of Stokes theorem, the closed line integral of E bar dot dl bar is equal to open surface integral of curl of E bar dot ds bar. As the curl of E bar is equal to 0, then definitely the closed line integral of E bar dot dl bar is equal to 0. But the expression of work is equal to minus q into integral of initial position to final position E bar dot dl bar. Suppose if the initial position is equal to final position, then closed line integral itself indicates that the initial position is equal to final position. So therefore we can say A bar dot dl bar is equal to 0. So therefore now work done in a closed loop is always equal to 0, because this integral will become 0. So therefore we can say the work done in a closed loop in a field, in a conservative field, is always equal to 0. Or we can even say conservative field, it indicates that whatever the work we are going to do in a field, if it is only depending upon the initial position and the final position, then we say that field is said to be a conservative field. Suppose there is a charge q, a big charge q, and I am going to bring a small amount of charge q from position A to position B. Suppose in this path I am going to take the charge small q from A to B, and this is, let me assume, it's a path 1. So the amount of work done in the path 1 is W1. Suppose I am going to bring the same charge small q from position A to position B in this path. The path is 2, but for the path 1 and the path 2, the initial position, the final position both are same, and the work done in the path 2 is, let me assume, W2. So in a conservative field, whatever the work you are going to do, it only depends upon the initial position and the final position, but not on the path you are traveling. So therefore, whatever the work done in the path 1 is equal to work done in the path 2. So this is called as a conservative field. If it is not equal, then we say it is a non-conservative field. So therefore, whenever the work done is independent of the path travel, but it only depends upon the initial position, the final position, then we say that field is said to be a conservative field. And always in a conservative field, here you can see from the expression also, the work is only depending upon the initial position, the final position. So if you make any closed loop integral, or we can say if you take any closed loop, then definitely initial position is equal to final position, then definitely it is equal to 0, then the work is also equal to 0. So therefore, in a conservative field, we can say if the work is depending upon only on the initial position, the final position, but it is independent of the path travel, that field is said to be a conservative field. Or simply we can say the closed line integral of A bar dl bar is equal to 0 means the work done in a closed loop in any field is equal to 0, then we say that field is said to be a conservative field. Means the curl of electric field should be equal to 0 with the help of Stokes theorem. Means there is no curling, only it is a diverging field, or we can say it is a irrotational field. So now we are going to solve the fifth question. See the question here. Given a vector field A bar is equal to 2 rho cos phi a rho cap in cylindrical coordinates, for the contour as shown below, what is the closed line integral of A bar dot dl bar is? So this question is same as the first question. So therefore, we are going to solve this question by two methods as we did for the first question. So out of these four options, option A is the correct solution of this question. So they are given a function A bar, and here this is a cylindrical coordinate system, and also here for this closed loop, so we are going to travel in this closed path. Then what is the closed integral of A bar dot dl bar, we need to figure out. So out of these four options, option A is the correct solution of this question, which is 1. So let's solve this numerical. So in this question, they are given A bar is equal to 2 rho cos phi a rho cap, and also they are given here, this is the contour we have to travel. From here we have to travel in this way. So therefore, in this closed contour, what we have to do is we have to figure out the closed line integral of A bar dot dl bar, we need to figure out. So now we are going to do this question same as the first question itself, which is the based on the Stokes theorem, the closed line integral of A bar dot dl bar is equal to open surface integral of curl of A bar dot ds bar. So therefore now I am going to use the method 1. So I am going to solve this RHS in the method 1. In the method 2 I am going to solve the LHS, and both the results will be same. So I am going to show you that also. So in the method 1 I am going to take this RHS. So therefore, the first I have to find what is the curl of A bar. So curl of A bar in cylindrical coordinate system, because rho and phi are belong to cylindrical coordinate system, so we have to write the expression of curl of A bar in the cylindrical coordinate system, which is 1 by rho determinant of A rho cap, rho into A phi cap, A z cap, dou by dou rho, dou by dou phi, dou by dou z, A rho into A phi into A z. So this is the things in the cylindrical coordinate system, and definitely what is going to happen is here A rho is nothing but 2 rho cos phi, but A phi and A z are 0 because they are not given the remaining coordinates. So therefore these two are 0. So I have substitute here remain to 0, that these are zeros, and in place of A rho I substitute 2 rho cos phi. And if you do the simplification of this one, finally we are going to get del cross A bar is equal to 2 sin phi A z cap. So we have figured out the value of del cross A bar. Now what is the ds bar? So ds bar is nothing but a small amount of area in this contour. So here this is changing, definitely this is changing in the rho axis and also in the phi axis. The change in length in the rho axis is d rho, and the change in length in the a phi axis is nothing but rho into d phi. So therefore area is nothing but d rho into rho d phi a z cap. So therefore now a small amount of increment in length in the cylindrical coordinate system is d rho in the terms of a rho cap, rho d phi into a phi cap plus dz into a z cap. So now if you want ds bar, the change in rho axis is d rho and the change in a phi axis is nothing but rho into d phi. So you have to multiply these two things and here a z cap, because it is orthogonal, it is always perpendicular, it is always outside the surface. So therefore this is the ds bar. So we know the value of del cross A bar and we also know the value of ds bar. So now just do the dot product of those two vectors. So if you do the dot product of those two vectors, this is also z cap and that is also z cap. So if you do the dot product, so simply we have to multiply those terms. So if you multiply, we are going to get 2 sin phi rho d rho into d phi. So this is what we are going to get. So this all expression we have got. Now we have to do the surface integral. So here rho is nothing but they have given 1, means rho is changing from 0 to 1 and phi is changing from 0 to pi by 2. So with the surface integral, rho is changing from 0 to 1 and phi is changing from 0 to pi by 2. This whole thing is nothing but 2 sin phi rho d phi. So this is an independent integral, so we can do the splitting. So 2 into 2 is outside and phi is changing from 0 to pi by 2, sin phi d phi into rho is changing from 0 to 1 rho d rho. So if you, this is 2, this overall integral will become 1 and this integral will become now 1 by 2. So if you do this one, 2 to get cancels. So finally 1 is the correct solution of this question. So now let us do this question by even solving the LHS, so which is the method 2. So now we are going to solve this by the second method, which is the closed integral of a bar dot dl bar. I am going to split this total closed curve into 3 paths. The path 1 is from here, the path 2 from this path, and this is the path 3. So therefore overall closed integral I have divided into 3 parts, path 1, path 2 and path 3. So I have to go for each and every path and then I have to finally add the results, then I am going to get the final solution. So now here a bar dot dl bar, what is the value? See, a bar value already they have given. So dl bar is nothing but in the cylindrical coordinate system, d rho into a rho cap plus rho d phi into f cap plus dz into az cap. So now you have to do the dot product of these things. So dot product is nothing but only similar exponent values, you have to do the multiplication. So therefore here a rho cap and here is a rho cap. So here you have to multiply these two components, so which is 2 rho into cos phi into d rho. So therefore now for the path 1, what are the variables? See, for the path 1, rho is changing from 0 to 1 and phi is a constant which is equal to 0 and z is also constant which is equal to 0. So therefore for path 1, rho is a variable which is changing from 0 to 1. So if rho is a variable, we can say though rho is not equal to 0, but for phi is a constant which is equal to 0 degree. So therefore we can say d phi is equal to 0 because it's a constant value. The change in phi is equal to 0 and similarly z is a constant which value is equal to 0. So if z is a constant, we can say change in z is equal to 0. So now all these constants you have to substitute in this integral. So integral for path 1, a bar dot dl bar is nothing but 2 rho cos phi d rho. If you see carefully here phi is 0, phi is already 0, so cos phi is nothing but 1, so 2 rho d rho. So d rho is not equal to 0, so now you have to go for the limits. Rho is equal to 0 to 1 because rho is changing from 0 to 1. So if you solve this integral, we are going to get the answer 1. For the path 1, the integral value is nothing but 1. So for the path 1, we got the answer, integral value is 1. So for the path 2, we have 2. This is the path 2. So for this path 2, the radius is constant, means rho is equal to constant which is equal to 1. And here the phi is changing from 0 degree to pi by 2 degree and that is also constant which is equal to 0. So the variables in the path 2 are so rho is a constant value which is equal to 1. See, if rho is a constant, we can say the change in rho is nothing but 0 and similarly phi is a variable because it's changing from 0 degree to 90 degrees. So therefore we can say if rho is a variable, then we can say d phi is not equal to 0 and similarly here z is a constant value because it is in the xy plane. So z is a constant value, so z is equal to 0. If z is a constant value, we can say dz is equal to 0. The change in z is equal to 0 because it is a constant value. So now the line integral for the path to a bar dot dl bar, already we have known the dot product of a bar dot dl bar which is 2 rho cos phi d rho. So phi is changing from 0 degree to 90 degree, but here is equal to changing, but d rho is nothing but 0 because rho is a constant. So d rho is nothing but 0. 0 into anything is again 0. So 0 into any integral is nothing but 0. So overall value is equal to 0 because this d rho is equal to 0. 0 into anything is again 0. So therefore the overall integral value of the path 2 is equal to 0. So for the path 1, we got the answer 1 and for the path 2, the integral is 0. So now you have to go for the path 3. So this is the path 3. So you have to go from this point to this point. So therefore rho is changing from 1 to 0 and phi is the value constant which is equal to pi by 2 and that is also constant which value is equal to 0 because it is in a xy plane. So therefore the variables and the constants in the path 3 are rho is a variable because it is changing from 1 to 0. If rho is a variable, we can say change in rho is not equal to 0, but if phi is a constant value, it is equal to pi by 2 degree. So therefore we can say that phi is a constant means d phi is equal to 0 and similarly z is a constant value because it is in a xy plane. So therefore z is equal to 0. So change in z is equal to 0 because it is a constant value. So now we have to substitute all these constants in the equation. So for the path 3 integral a bar dot dl bar, already we have known a bar dot dl bar is equal to 2 rho cos phi d rho. The line integral is from rho is equal to 1 to 0, but if you see carefully carefully, phi is a constant value which is equal to pi by 2. So cos pi by 2 is nothing but cos 90 is nothing but 0. So 0 into anything is again 0. 0 into any integral is again 0. So therefore the answer is equal to 0. So therefore for path 3 the integral value is equal to 0. For the path 1 we got 1, for path 2 we got 0, and for path 3 we got 0. So now you do the addition of 1 plus 0 plus 0, it is equal to 1. So therefore even by both methods, even by LHS and RHS, we got the same answer which is 1. So in the examination it is up to you which method you are going to prefer in order to solve this type of questions. So now we are going to solve the sixth question. See the question here. Which one of the following pairs is not correctly matched? So here they are given 4 options. Out of these 4 options, which statement is wrong? So out of these 4 options, option C is the correct solution of this question, which is not correctly matched. So now we'll discuss the solution of all this one. This question they are given 4 options. Now we will discuss each and every option in a very detailed manner. So the first option is nothing but it is a Gauss divergence theorem. Gauss divergence theorem is going to relate a closed surface integral with a volume integral, because always a closed surface can only give you a volume. So therefore this Gauss divergence theorem is going to give you a relationship between a closed surface and a volume, because a closed surface can only enclose a volume. So closed surface integral of d bar dot ds bar. See, d bar dot ds bar is equal to closed volume integral of divergence of d bar into dv. So this is the relation between a surface integral and a volume integral. And also the Gauss law. See, the Gauss law is nothing but it is going to use the Gauss divergence theorem. See, Gauss law is going to tell you the amount of flux which is passing through a closed surface is equal to the amount of charge enclosed by that closed surface. So therefore the amount of flux closed surface is nothing but closed surface integral of d bar dot ds bar is equal to the amount of charge enclosed. We can write in another fashion, which is volume integral of charge density, the volume charge density into dv. So this is the Gauss law. Basically in the Gauss law we are going to use the Gauss divergence theorem. Then only we are going to get one important formula, which is del dot d bar is equal to rho v, means the divergence of electrical flux density is equal to volume charge density. And also the option C is nothing but it is a Faraday's law. In the option they are given actually it is a Coulomb's law. That is wrong. This is actually a Faraday's law, which is voltage induced is equal to negative of, we can say, derivative of change of magnetic flux. So therefore whenever there is a rate of change of magnetic field in a given closed loop conductor, then we can say there is a voltage or EMF is going to induced in that conductor. So therefore whenever there is a rate of change of magnetic field or magnetic flux, the voltage is going to get induced. This negative is nothing but it is a Lenz's law. It is always going to oppose the cause. So therefore V is equal to minus d phi m by dt. This is called as the Faraday's law. This negative is because of the Lenz's law, and the overall equation is given by Faraday. So we say it is a Faraday's law. And the last one is the Stokes theorem. Stokes theorem is going to relate you a closed line integral with a open surface integral, because a closed line only can give you an open surface. So therefore closed line integral of any vector E bar dot dl bar is equal to open surface integral of curl of E bar dot ds bar. Always the length, the area are vector quantities, but a volume is a scalar quantity. Because of that reason there is no dot product or no dot product for the volume, but the length and area are the vector quantities. So that is the reason we have to go for the dot product. So these are some of the important formulas or important laws in a EMT subject. So now we are going to solve the seventh question. See the question here. What is the value of the integral, the curve integral of, means the line integral of dl bar along the curve C, where C is the curve ABCD in the direction of the arrow. So basically here we have to find the integral, the line integral of the curve ABCD of dl bar we need to figure out. So this total circle is of radius r. So out of these 4 options, option D minus 2r a cap is the correct solution of this question. So let's solve this numerical. So now here in this question they are asking what is the contour for the path ABCD dl bar we need to figure out. So this is the contour ABCD. So in this contour we have to find what is the line integral we need to figure out. So therefore the circle is of radius r. So basically here this is a xy plane, x and y plane. So now I am going to split this into 3 parts, AB, BC and CD. So therefore I have made this total into 3 parts, AB, BC and CD. So here in the Cartesian coordinate system a small amount of incremental of length is dx ax cap plus dy ay cap, whereas in the cylindrical coordinate system a small amount of increment is d rho into a rho cap plus rho into d phi a phi cap. See here this is a xy plane, so no need to take the another component of z axis because it is a xy plane. So now listen, for the path AB I want to find the contour. So for the path AB, I want to find the integral. Suppose if you take a Cartesian coordinate system DL, what is going to happen? Suppose for the path AB, if you take a Cartesian coordinate system, x is a variable and y is also a variable. So I don't want two variables. I want only one variable, so that simplification will be very easy. But if you take a cylindrical coordinate system, so if you take a cylindrical coordinate system, the radius is constant, the only variable is phi. So here, if you take a cylindrical coordinate system for the path AB, one rho is a constant but phi is a variable. But if you take a Cartesian coordinate system, x is a variable and y is also variable. So that is the reason I am preferring for the path AB in the terms of cylindrical coordinate system. So therefore, for the path AB, DL bar, I am going to use the cylindrical coordinate system because one variable is a constant and other is a variable. So therefore, DL bar is equal to d rho a rho cap plus rho d phi a phi cap. So now, what are the variables and constants for the path A and B? For the path AB, rho is a constant, its value is equal to radius of the circle. See, whenever rho is a constant, we can say the change in rho is equal to 0, whereas phi is a variable because phi is changing from 0 degree to pi by 2 degree. So therefore we can say it is going from 0 to 90 degree. So whenever phi is a variable, we can say d phi is not equal to 0 because phi is a variable, whereas z is a constant. So we can say it is a xy plane. See, z is a constant, or we can say z is equal to 0. So whenever z is a constant, we can say dz is equal to 0. See, no need to write the third one, but I wrote for a purpose, I wrote the third one also. So now you have to keep all these constants in this equation. So here, if you see carefully here, d rho is equal to 0 because rho is a constant, so this value will become 0. But only thing is rho d phi a phi cap. Rho is a constant, its value is equal to r. This is d phi and a phi cap. The value is from phi is equal to 0 degree to pi by 2. So if you do this integration, we are going to get r is a constant, we can take outside. So integration of d phi is phi, upper limit minus lower limit. So finally we are going to get r pi by 2 a phi cap. So for the path AB, the value of the integral is r pi by 2 a phi cap. So now we are going to do the same procedure for the path 2 and also path 3, and then we are going to add all these results and then we are going to get the solution. So now I am going to do this integral for the path BC. So if you see the path BC, there are two variables. If you take the cylindrical coordinate system, see, rho is changing from plus r to minus r and phi is changing from plus 90 degree to minus 90 degree. So if you take the cylindrical coordinate system, there are two variables, rho and phi. But if you take a Cartesian coordinate system, x is nothing but 0. It is a y-axis, means x is a 0, but only variable is y. Y is changing from plus r to minus r. So therefore I am going to prefer which is having less variables. So therefore for a Cartesian coordinate system, it is less variable, only y is a variable. But for a cylindrical, there are two variables. That is the reason I am going to use only the Cartesian coordinate system because it has a less variables for the path BC. So therefore integral of BC dl bar I am preferring the Cartesian coordinate system because it has less variables. So dx ax cap plus dy ay cap. So now what are the constraints? Because x is a constant value, it is equal to 0. If x is a constant, we can say dx is equal to 0. But y is a variable, it is changing from plus r to minus r. If y is a variable, we can say dy is not equal to 0. So now I am going to keep these constraints in this equation. So here x is a constant, so therefore dx is equal to 0. So this will become 0. So 0 plus dy ay cap. So this is 0. So you have to remove this one. Y is changing from plus r to minus r, and this is dy ay cap. So integral of dy is nothing but y. Upper limit is minus r, lower limit is plus r ay cap. So upper limit minus lower limit. So minus r ay cap. So minus r is nothing but minus 2r ay cap. So therefore for the path BC, dl bar is nothing but minus 2r ay cap. So now we are going to do for the path 3 also from Z to D. So now for the path CD, this is the third path. So if you see carefully, if you take the x for the Cartesian coordinate system, x is a variable and y is also variable. So we don't want to take two variables. But if you go for a cylindrical coordinate system, the radius is constant, which is equal to r, and phi is changing from minus pi by 2 to minus pi. So it is changing from minus pi by 2 to minus pi. So therefore we can say here, for cylindrical coordinate system, rho is a constant, only phi is a variable. But for a Cartesian coordinate system, x is a variable and also y is also variable. So we are going to prefer that one which has a less number of variables. So therefore I am going to prefer the cylindrical coordinate system because it has only one variable. So therefore for the path CD, dl bar, I am going to prefer the cylindrical coordinate system because it has less variables, which is d rho a rho cap plus rho d phi a phi cap. So now what are the variables and constants? So here rho is a constant, is equal to radius is equal to r. If rho is a constant, we can say change in rho is equal to 0, but phi is a variable. It is changing from minus pi by 2 to minus pi. So therefore, if phi is a variable, we can say d phi is not equal to 0. So now you can do these constraints. You can apply these constraints in this equation. So d rho is a constant, d rho is 0. So therefore, this value will become 0, and rho is equal to constant value. It is equal to r d phi a phi cap. So 0 plus r d phi a phi cap. So this is 0. So r is a constant. You can take outside. So integration of d phi is nothing but phi. So substitute the limits minus pi by 2 to minus pi a phi cap. So upper limit minus lower limit. So finally we are going to get r of minus pi plus pi by 2 a phi cap. So minus pi plus pi by 2 is nothing but minus r pi by 2 a phi cap. So therefore, for the path 3, we got the integral minus r pi by 2 a phi cap. So now we are going to add all the 3 path integrals, and then we are going to get the solution. See, overall path integral ABCD dl bar is equal to, we have divided into 3 paths, and we have did the integration for each and every path. We got the result. For the path AB, we got the result r pi by 2 a phi cap, and for the path 2, we got the result minus 2r a phi cap, and for the path CD, we got the result minus r pi by 2 a phi cap. So these are same. So therefore, we can say these are going to get cancelled of each other. So only thing which is remaining is minus 2r a phi cap. So therefore, the overall path integral ABCD dl bar is equal to minus 2r a phi cap is the correct solution of this question. See, only thing that you have to remember is, see, out of this Cartesian and cylindrical, you have to choose only that one which has a less number of variables, or we can say it is easy for calculation. So I have chosen in that way. For the path AB, I have choose the cylindrical coordinate system because it has less variables, and for the path BC, I have choose the Cartesian coordinate system, and for the path CD, again I have choose the cylindrical coordinate system because the variables are less there. So if you take the variables less, the simplification will be very easier, and you can get the solution in a very short amount of time. So now we are going to solve the 8th question. See the question here. The maximum space rate of change of the function which is in increasing direction of the function is known as. So in this question they are asking about the maximum rate of change of in which direction it is going to happen. So out of this, it is going to define by which quantity. So out of these 4 options, option B is the correct solution of this question, which is the gradient of the scalar function. So now we'll discuss this question. So now let me tell you a small concept of the gradient. Suppose this is a equipotential surface of potential V. Suppose this is another equipotential surface of value V plus dV, and there is another equipotential surface of value voltage is V plus 2 dV. Means at each and every point on this line will have the same potential, which is V, and similarly the each and every point on this graph on this line is also going to have the same voltage, which is V plus dV, and the each and every point on this line will have the same potential, which is V plus 2 dV. Suppose I am going to move in the increasing direction of the scalar function, means this is a V and this is V plus dV. It is an increasing function. So now I am going to move from this graph, from this line to the another line or another equipotential surface in the 3 paths. Let me choose the path is, this is PQ path, second path is PQ dash path, and the third path is the PQ double dash path. So the length of PQ is L, and the length of PQ dash is L dash, and the length of PQ double dash is L double dash. So here along PQ, the rate of change of voltage with respect to distance is how much amount of change with respect to voltage. The voltage change is dV because this is V and this is V plus dV. The rate of change is dV, so dV by L. Along PQ dash, the rate of change of voltage with respect to distance is dV by L dash, so dV by L dash. Along the path L double dash, the rate of change of voltage with respect to distance is dV by L double dash. So dV is same for each and every path, but only thing is the length is going to get vary. Suppose I am going to assume that L double dash is greater than L dash is greater than L. If the denominator is decrease, then we can say the overall value will be very higher. So here denominator is very more, so therefore overall value will decrease. So this is a very least value. So therefore we can say dV by L is greater than dV by L dash is greater than dV by L double dash. It indicates that the rate of change of voltage is same in each and every path you are traveling, but only thing is the distance. If L is very less, then we can say dV by dl, or we can say dV by L is very high. It indicates that you have to move in such a direction, the minimum distance between the equipotential surfaces. If you travel in a minimum distance between the 2 equipotential surface, then the rate of change of voltage with respect to the distance will be very high. That is the meaning of a gradient. So gradient is always always going to give you a path. If you travel along that path, then definitely we can say the rate of change of voltage with respect to distance will be very, very high. That is the meaning of a gradient. It always gives you the direction in which if you travel in that path, the rate of change of voltage with respect to the distance will be very, very high. That is the meaning of a gradient. So gradient of any scalar function will be always perpendicular, because always between any two lines the perpendicular distance will be always minimum. So because the perpendicular distance between any two lines will be always minimum, so therefore always it is perpendicular to the equipotential surface or any scalar function. So the gradient of any scalar function will be always perpendicular to that scalar function, which is of 90 degree. So finally we can say that the maximum space rate of change of the scalar function which is in the increasing direction of the function is known as the gradient of the scalar function. Means the maximum rate of change of the scalar function which is in the direction of the increasing of the function is known as the gradient of the scalar function. It indicates that the function is increasing from v to v plus dv. So if you are moving in the increasing direction with a minimum distance, then we can say the gradient is higher. So the maximum space rate of change of scalar function which is in the increasing direction of the scalar function is called as the gradient of a scalar function. So now we are going to solve the 9th question. See the question here. For electrostatic fields in charge-free atmosphere, which one of the following is correct statement? So here in charge-free condition for the electrostatic field, what are the conditions which are going to satisfy? So out of these four options, option A is the correct solution of this question, which is the curl of electric field is equal to 0 and divergence of electric field is equal to 0. So now we'll solve this question. So now we will see regarding the electrostatic fields in a charge-free condition. Charge-free condition means the charge is somewhere very, very far. So because of the charge, some amount of electric field is going to get present. Suppose I am going to take a closed surface. Some closed surface. So here the electric field is going to enter this closed surface and the electric field is going to leave the closed surface. Means the number of electric field lines which are entering is equal to the number of electric fields which are leaving the surface. So we can say whatever the inflow is equal to outflow. So therefore we can say the divergence is equal to 0, because divergence is going to tell you whether any net amount flow is present or inflow is present. But here the inflow is equal to outflow, therefore we can say the divergence of electric field is equal to 0 in a charge-free condition. Because there is no charge present here, it is somewhat far present. Because of that, the electric field passing through any closed surface, here it is definitely equal to 0, because whatever the inflow is equal to outflow. So therefore divergence of electric field is equal to 0, because whatever the inflow through this closed surface is equal to the number of field lines entering this closed surface is equal to the number of field lines leaving this closed surface. So net amount of which is going to present inside is 0. So that is the meaning of this one. So always electrostatic electric field is a conservative field. I have already told you electrostatic electric field is always a conservative field, but not the time varying electric field. So always you have to remember only the electrostatic means the electric field which is produced due to static charges. That electric field will be always conservative in nature. Means the work done is going to depend upon only the initial path and the final path, but it is independent of the path you are traveling. So therefore we can say the curl of electric field is equal to 0. So the curl of electric field is equal to 0 and divergence of electric field is equal to 0 in a static, or we can say in a charge-free condition. Suppose if there is a charge is present for the electrostatic fields, suppose a charge is present, then what is the nature of the del cross E bar and del dot E bar? See, always whether a charge is present or charge is not present, always the electric field is always going to diverge. It is always going to diverge, means there is no curling effect. Curling effect is not at all present in the electric field. So definitely we can say curl of electric field is equal to 0, because no matter whether charge is present or not, the electric field nature is always going to be diverging. So there is no curl effect. So we can say curl of electric field is equal to 0. Now we'll discuss about the divergence of electric field. Suppose there is a charge Q. So now I am going to take a closed surface. So from this closed surface, because this charge is going to, positive charge will always radiate the electric field outward. So electric field will be flowing out of this surface. So therefore we can say through this closed surface a net amount of electric field is outflowing. So therefore we can say diverging, the field is diverging the closed surface, means the divergence is greater than 0. It means it is not equal to 0. Therefore we can say the divergence of electric field is not equal to 0, because some amount of flux is outflowing the that surface. So because of that reason, the divergence of electric field is not equal to 0 if any charge is present. If there is no charge, we can say the divergence of electric field is equal to 0. But the curl of electric field will be always equal to 0 because it is independent of the charge. It only depends upon it is going to radiate outward. It is always going to radiate outward. There is no curling effect in the electric field. That is the reason curl of electric field will be always equal to 0. So now we are going to solve the last question of this lecture. See the question here. If the electric field established by 3 point charges q, 2q, 3q exerts a force 3f bar and 3q and 2f bar and 2q, then what is the force exerted on the point charge q? So here there is a system of 3 charges q, 2q and 3q. So because of these 3 charges, the force on the charge 3q is 3f bar and the force of 2f bar on charge 2q. Then we have to find what is the force on charge q. We need to figure out. So out of these 4 options, option D minus 5 f bar is the correct solution of this question. So let's solve this numerical. Basically here, suppose there is a system consisting of 3 charges q, 2q and 3q. So because of q and 2q, amount of force applied on the 2q charge is 2f bar, and because of q and 2q, the force on the charge 3q is equal to 3f bar. Then what is the force on q? Because of the remaining charges we need to figure out. Suppose if you take a small example of a car. Suppose there is a car in the front seat, you just came and you sat down in the first seat, driving seat. Then and you are pushing the car with the help of your hands. You came and just sat in the driving seat and you are trying to push the car forward with your hands. See, your force is going to exert a forward force on the car, but your legs are going to produce a outward force, means opposite force, means you have to push your legs backward, then only you can apply a force on the forward in the direction of the car. So therefore your hands is going to exert a positive force, means in the direction towards the car or outwards the car, but the legs are going to produce a force which is opposite to the car direction. So because of this, the net force, this is in this direction, your hands is going to exert a force in this direction on the car, but your legs is going to exert a force in the opposite direction to your hands. So therefore we can say the net force is equal to 0. So because of that, a car doesn't move. Even if you are sitting in the car and if you are trying to push the car from inward, because of the net force is 0, means your hands is going to exert a force in this direction, then your legs will be exerting a force in the car in the opposite direction. So therefore the net force on the system is 0. So because of that reason, the car is not able to move. So therefore even in these charges also, these charges are not able to move at steady state because the net force applicable on the system is 0. Because of that reason only these charges are going to stay in the at equilibrium, they are going to stay in a stationary position. If anything is stationary, means the amount of forces applying on the system is equal to 0, then only we can say the objects are in the steady state, or we can say it is a rest condition. So therefore at equilibrium total force on the system is 0, then only these charges are going to stay at equilibrium at a steady state condition. They are at a rest condition. So therefore force are always a vector quantity, so you have to add in a vector way. So therefore Fq bar plus F2q bar plus F3q bar means force on charge q, force on charge 2q, force on charge 3q is equal to 0. But already in the question they are given the force on charge 2q is 2f bar and the force of charge 3q is 3f bar is equal to 0. So therefore force on charge q bar plus 5f, 3 plus 2 is 5f bar is equal to 0. So force on charge q is equal to minus 5f direction. So therefore this is the correct solution of this question. See, because of these two, the charges are in the positive direction, so therefore here it has to be negative. Then only we can say if one is in the positive direction, then definitely the other force should be in the negative direction. Then only we can say the net force is 0. Then only the net force is 0 indicates that system is at under a stable condition or the rest condition. So by this lecture we have successfully completed the 10 questions which are the previous year questions of the electromagnetic theory of ESE doubly in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button so whenever we upload a new video the direct notifications comes on mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.